everyone! This is a servo tester. Look at it. We're going to learn in this video how to read the value, the signal of a servo tester like this. And you might think, Mr. and Eric, why do I care? Well, this kind of signal that comes from a servo tester is the same kind of signal that's used to drive a servo, to make a servo turn, and is also the same kind of signal that is output with a radio receiver. So this receiver here, if you're remote controlling it with your radio transmitter, on these pins will output the same kind of signal. So if we know how to do this, then we can read remote control signals, radio control signals, I should say. So that's the goal. Let's see how we can read a servo signal. The kind of signal from a servo signal is called PWM, pulse width modulation. So let's see if we can write a program to get it working. First of all, we will need to wire it up. I noticed that this has, it's got in and out. I don't really care about in right now, but I do care about the output because this will output a signal. And you might notice that there's a negative for ground, a plus for your positive voltage, like your 5 voltage, and an S. The negative and the plus, I will do them first. They are used to provide power to this because this needs power to run. It needs 5 volt power. So I'll get my ground, my negative, and I will plug that into any of the ground pins on my Arduino or on my motor shield here. Because I'm using the motor shield, I notice that there's servo 1 and servo 2 here, and they're labeled negative, plus, and signal. So I'm going to plug this into the negative. So the ground, the negative from here, goes to the negative here, and the plus, the positive voltage, I need to give that 5 volts. So the plus here will go, it says negative plus S. So this middle one is plus. That's promising. So now I've got power. And now this other pin is for the signal, the PWM signal. So I'll plug this one in and plug that into here. So now this has power, and whenever I turn this knob, the current value of the servo tester will get sent as a PWM signal through this, well, this yellow wire here, to the S in there. All right, so it's wired up now. Well, how do I test it? How do I read it from our Arduino? There is something we can use called pulseIn. Let's have a little googly to find that. pulseIn. There we go, there's the one. So if you Google pulseIn, you'll find the documentation on the Arduino website, and it says it reads a pulse, a PWM pulse. If the value is high, pulseIn waits for it to go from low to high, starts timing, and then waits for it to go low and stops timing. So it times how long one pulse is, and it returns the length of the pulse in microseconds. It returns how long the pulse was. So we'll be able to read the value because this sends long pulses when it's on maximum and shorter duration pulses when it's on minimum. How do we use it? Well, we need to tell it which pin it's connected to. We need to tell it which kind of pulse we're reading, high or low. And this last one is optional, I will ignore it. Here's an example here, and this example looks pretty good. Actually, I quite like this example. Sets the pin up here, makes a variable for the duration, starts the serial port to send data to the computer. Serial is how we can send data to or from the computer. It says that we are going to use this pin as an input pin. That happens once because it's in the setup function. We have another function here called loop that will run over and over and over and over and over and over again forever. And what does it do in the loop? Well, it updates this duration variable that we declared here and sets it to be, well, it sets it to read a pulse. It says read a pulse on that pin and then print it to serial. Right, good. I might actually start with a very similar example. If I go File, Examples, Basics, my favorite example for testing reading data from anything in Arduino, whether it's a sensor or a servo tester, is called Analog Read Serial. And you'll find it under Examples, Basics, Analog Read Serial. So let's open that one up and modify it to use pulseIn. So there's some comments describing how it works. It says that it's going to use pin A0, and sure enough, it's using analog read to read the value of pin A0. I don't have anything plugged into A0 at the moment, so if I upload this right now, I would expect to see maybe just zeros or maybe just random numbers because nothing is plugged into pin A0. Let's try it. So this is the same thing, sets up the serial port in setup, declares a variable called sensor value, and the data type of this variable is int or integer. An integer means a whole number. Let's see that this works, first of all. I know I'm not reading from my servo, I'm reading from pin A0 and nothing's connected. So we'll just check that we can see something. Looks like it is still stuck uploading. Might try uploading again. Or maybe unplug and plug back in and see if that works. There we go. Done compiling, uploading, done uploading. There we go. That's how you know that it works when it says done uploading. Let's go to the serial monitor and check that I can read values. Yeah, good. Sort of random numbers because it's pin A0. You may find if you put your finger on pin A0, which is, maybe touch some of the other ones as well, that it changes a little bit, maybe. Yeah, it did a little bit. But that's not really what I care about. I don't care about pin A0. I care about the servo tester, which is going into this pin here. We can have a look at the documentation. What do we have? We have an Adafruit motor shield. We can have a look. There we go. There's some documentation about it. I think there is a manual or a PDF that describes how that motor shield works and all the pins and everything. If I have a look, what's that? Parts list, motors, resources. I'm just going to flick through until I can find what I'm looking for. Pins? Ah, there we go. So the servo input or output, these ones here, are on pin 9 and pin 10. Let's try pin 10. I can't remember which one is which. Let's try pin 10. And instead of using analog read, I want to read it as a PWM input. So I use pulseIn. Oh, pulseIn expects some extra arguments, some extra parameters. I only told it the pin, but I also need to tell it whether I'm waiting for it to go high or waiting for it to go low. And if I go back to the documentation tells me that I need to give it a pin and also whether I'm waiting for it to go high or low. That's the value here. So let's wait for it to go high and see how long it is high for. Usually if you're reading PWM input, you'll want to wait for it to go high. So that will always be high. All right, now it compiled without errors and it's done uploading, so I can test it in the serial monitor. Okay. Oh, I did get the right one, yay. So if I go all the way down here, it gets smaller, and all the way up there, it gets bigger. Very, very cool. Nice. Another cool tool that the Arduino IDE, this Arduino code editor, gives us, an IDE is another name for a code editor, is a serial plotter. So as well as looking at the values that are being sent through serial.println, we can click on this button and we can graph them. Whee! If you leave it still for a while, you will notice that the graph adjusts for the last, 100 values or so for the minimum and maximum. So it looks like it's changing a lot. But if I actually look at the numbers on this axis, it's going from 1,390 to 1,397. So if I change it a lot, then you can get a better idea about the lowest numbers you can get and the highest numbers you can get. All right, I think that is enough for now. Give that a go, see if you can set it up and have a play, and I'll see you in the next video. Bye everyone.